This is Math 1010. This is our first section, which is not going to be on the test. It's just called review. Mostly think of it as a technology introduction. I want you to do all of these problems, well, most of these problems, on the calculator, and then some of them are just for you to do, hopefully mentally, but you may not have seen them for a while. So again, we're going to review. First, we're going to convert from a percent to a fraction. This is one of the calculator skills that you want to have. Many of you have probably not used TI-83 or 84 specifically, so we want to use the technology we have when we have it, because the arithmetic and finding common factors and stuff, that's not what we're here for anymore. So I'm assuming you have your calculator with you. I'm going to have to talk you through it. If you have trouble seeing what I'm talking about, there's a paper guide that you can find on D2L, and there's a short video that you can find in the integrity lectures that will literally show you the buttons you need to push to do this. If I want to change 23% from percent notation to a fraction, the thing that I want to note first is that the word percent tells me what to do. Per means divide. Cent means 100. So I want to take 23% to change it to a fraction. I literally want to do 23 divided by 100. Now when I hit the division key on the calculator, after I type in 23, I hit the button that looks like this, but it just makes a slash. So it's actually going to look like a fraction to start with. So 23 divided by 100. The question about this is once I make it into a fraction, does it reduce? Well, to find out, on your calculator, you have a math key. It's on the left. A couple buttons above the numbers. I think it's the third or fourth one down. But it says math. If you hit the math key, you'll see a whole bunch of functions that your calculator will perform. The very first one, which is already highlighted, has an arrow and the word frac. That literally means give me my answer in the form of a fraction. So if I hit the math key once, I'll see that. Then I need to hit enter, and when I hit enter on my home screen, next to my 23 over 100, it'll put that command, colored in arrow, and the word frac, and that means 23 over 100, I want it to give me a reduced fraction answer. When I hit enter again, the calculator gives me back 23 over 100. That's because 23 over 100 doesn't actually reduce. So you're not going to get any big fussing for typing in a fraction that doesn't reduce. It just gives you your answer back. Now, 6%. On the calculator, I type in 6 divided by 100. Then I hit my math enter. Hit the math key so that you can see the fraction command. Hitting enter once puts it on the home screen, which is where it would be performed. Hitting enter the last time actually reduces the fraction, and this one does reduce to 3 over 50. Now if I want to do a percent that has a decimal in it, your calculator doesn't care. It's not scared. You just do 14.5 divided by 100. You hit the math key to see the fraction command. You hit enter to put the fraction command there on the home screen. You hit enter one more time for it to perform the command, and we get 29 over 200. Now, if I want to go back and forth from percent to decimals and decimals to percents, I don't want to have to use my calculator to do that. In fact, it's a hindrance. To change from percents to decimal and decimal to percents just involves moving the decimal point around. If I put decimal and percent in alphabetical order, decimal would go first for D and percent would come second. This is just a little thing to help your brain tell you which way to move the decimal point when you have those little brain fart moments. If I have 20%, 20% is a percent, which means you should think of the percent or the decimal being on the right. If I want to go from percent to decimal, I have to move to the left. So, if I have 20% and I don't see a decimal, the decimal point is automatically there after the 0. I have to move the decimal point twice. I can only move it left or right. If I started with percent notation, to go to decimal notation, move to the left. So move the decimal point 2 places to the left means your answer is going to be 0.20. 2%, the decimal is right after the 2. Now, if I have 2 and I move the decimal point 2 places to the left, I can't just put decimal point space 2. You have to fill in there with a 0. So 2% is 0.02. If I could see the decimal point, that's just great. I move it 2 places to the left. To go from percent to decimal, I'm going to the left. Again, I have to fill in my empty spot with a 0. Now I got too many numbers, but the decimal point is still at the end. So 128, decimal point here, the rule doesn't change. That was percent notation. To go to decimal notation, I move 2 places to the left. That puts the decimal point between the 1 and the 2. If I want to go the other way, well, we're still in alphabetical order here. The difference is, if I have a decimal, I'm going to start here. To go from decimal to percent, I have to move to the right. That's the direction I need to move my decimal point. So if I see 0.45, I need to move my decimal 2 places to the right to make it a percent. That means it's 45, and I don't have to put the decimal point because it would be after the 5. Once I change it to percent notation, I have to have the percent sign. It's literally wrong if you don't have the percent sign and you just move the decimal point. 0.03, 2 places to the right, makes 3%. I don't need those zeros in the front of the 3 because we just don't write numbers that way. 2 has a decimal point here. And if I move it 2 places, just like before, I can't have a 2 with 2 empty places and then the decimal point. So I have to fill in 2 zeros, which puts the decimal point 2 places further to the right than when it started. And again, don't forget your percent sign. When I can see the decimal point, that's fantastic. Just make sure you're only moving it 2 places to the right. Puts the decimal point between the 6 and the 3. And there we go. Last but not least, to convert a number from a fraction to a percentage, this is going to take us 2 steps, and it is going to take us using the calculator again, unless you just like doing long division by hand. On the calculator, you do want to do 1 divided by 4, because remember, It's going to look like 1/4 when I do it on my calculator anyway. So I do 1 divided by 4, but I don't want a fraction anymore. I had a fraction. I want a decimal answer, so I just hit enter. When I just hit enter, I'll get 0.25. That's decimal notation, and then I've got to change it to percent notation. So from a decimal to percent, remember to go from D to P, I got to go right. So that decimal point moves 2 places to the right. And when I move the decimal point, I have to put my percent sign. Now on my calculator, if I do 3 divided by 8, I get 0.375. Move my decimal point 2 places, and I get 37.5%. And when I do 5 divided by 9, that one's a bear. I get 0 with a whole bunch of 5s. Well, I only need 3 decimal places, but what that means is I need to observe 4. So this is not my answer. And my answer, I just want 3 decimal places. So I know I'm going to have 0.55. The question is, what's the last digit going to be? To figure out what the third digit is, I have to look at the number that comes after it, the 4th digit. If that number is 5 or more, I'm going to raise this number to a 6. If the digit that comes after it is 0 through 4, I'm going to leave this digit a 5. Well, the number after it is 5 or more, which means my last digit is going to be a 6. Now, I'm pretty consistent about this. I generally ask for 3 decimal places or 1/10 of a percent, which is what you'll get when you move your decimal point over on a 3-digit number. There's 2 exceptions. I'm very clear about them being exceptions. So, except for those, you could pretty much count on that's what I'm wanting. Ratios are nothing but fractions. Ratios, again, this isn't going to be test material by itself. It's just another way to get you to play with your calculator and to convert between fractions, decimals, and percents. If I want to write the ratio of A to B, that literally means I want to write a fraction of A over B. So if A is 10, that goes on top, over B, which is 2, and I want to reduce that fraction. Now I know you can probably do 10 over 2 in your head, unless you've had a really long summer. But it's easy to practice your calculator with the stuff where you know what the right answer is going to be. That way you know you push the buttons right. So it kind of builds your confidence in your tool. If the only time you push the buttons is when you have no idea what the answer is, you'll have no clue whether you can rely on your technology or not. So go ahead and do 10 over 2 and math enter, and it'll just give you the answer 5. If I want to do the ratio of B to A, I'm doing the same thing but upside down this time. B, which is 2, goes on top. A, which is 10, goes on the bottom. Again, let's do the math enter, and let the calculator tell us the answer when we can sort of reassure ourselves that, yeah, that's right. Now, if I want to convert the ratio to a percent, I have to follow whichever of the rules I had before that apply. 5 isn't a fraction. 5 is just a decimal. So if I have 5 as a decimal and I want to change it to percent, I have to move the decimal point over 2 places. I have to fill those places in with zeros. So A is 500% of B. If I want to know what percent, well, B is what percent of A, 1/5 is a fraction. So on my calculator, I would do 1 divided by 5 and get the answer as a decimal. Now that decimal has to be changed to percent. Percent is what I'm looking for. So I move the decimal point over 2 places, fill in with zeros, and B is 20% of A. Equations, we're really not going to solve equations very much. I really try to get around that. So instead, what I've got you doing here is just checking possible solutions. Cross out the ones that are false, and the ones that are true you just leave alone. So essentially what I'm saying here is this. If I think my solution is 16, then I plug in 16 where the x is. So I'm going to do 16 minus 10 on my calculator. And then I'm going to hit enter, and that's going to give me 6. 6 is the answer I was told that I should get. So 16 appears to be okay. What happens if I plug in 9 where x was? I would do 9 minus 10, and I would get what? -1. -1 is not 6. So that solution is false. If I have 5 bumped up against x, that means times. So on my calculator, what that means is I want to do 5 times 4. Now don't hit enter, because part of what we're practicing here is calculator. You should type that whole left side in. So 5 times 4 minus 1. And that should say 19. It matches. 4 works. What about -7? Now I've been typing in minus on the last 2 problems. On your calculator, negative is a different key. Negative is the key that's down at the bottom, the little negative in parentheses. So if I want to type in 5 times -7, I type in 5 times, don't use the minus, use the little negative on the bottom, and then minus 1. 5 times -7 minus 1, when I hit enter, should give me an answer of -36, which does not match the 19 we were supposed to get for an answer. So -7 is not a solution. See if you could do the last 4 by yourself. Pause this recording and then start it back up and see if you did it right. Check it with me. To check x is -1, I would do 5, the big minus, 4 times the little -1, minus 6, this is the big minus, times little -1, equals, and I believe that'll give you 15. 15 does not match -5, so that solution does not work. If I want to check the 1, 5 minus 4 times 1 minus 6 times 1, that should give me an answer of -5. So +1 does work. Now the last one, I have to do each solution twice. I've got to plug in for x here and plug in for x here, and they're on 2 different sides of the equal sign. So if I do 3 times 2 minus 4, I get 2 for an answer. I don't care what I got for an answer with just plugging it in once. Now I need to plug it in the other side. 2 times 2 plus 6 equals 10. These two don't match, so 2 is not a solution. If I do the 10, 3 times 10 minus 4 is 26. Remember, on your calculator, I'm not doing this in my head, I'm pushing buttons. The second half, 2 times 10 plus 6 also equals 26. Again, I don't care what this number is over here. What tells me it's correct is that both sides match. So x equals 10 is a solution.